Okay, typical London DevOps tradition, I've whistled on for too long and put the timings all out, so the pizza is here and we haven't finished the talks. So we're going to have a quick break now. There's pizza that side and that side, so don't rush that way. So we have 15-20 minutes and then we'll have the final talk from Gabriel about chaos engineering. Thanks everyone. Okay, well done. 10 out of 10 for the pizza rating. Fantastic. Thank you everyone. Right, so, oh my god, it's almost 9 o'clock. It's like nobody's got homes to go to, right? Okay, so we're coming to the final talk of the evening. So we're very patient waiting for a slot. I'd like to introduce to you Gabriele Cismondi. I go to the Italian. I should sit down really. It's going to talk about chaos engineering. So big hand for Gabriele, please.
Thanks for staying for us today. That's already a big achievement. Well, as you said, my name is Gabriel, so this is my Twitter handle and my email, if you want to contact. Just before I start, let me say something about what I do and who I am. So I'm quite excited because I recently joined a very nice startup which is focused on AI, and we're trying to simplify the relationship between data and people. And we released last year Krista, which is the first virtual advisor for business intelligence. If you have some time, just check it out. It's a very cool thing. We are very passionate on building our own stuff, so we try to do everything we do in-house. But that's it. I don't want to spend too much time on this. Let's go to the main topic, which is chaos engineering. Trying to make it easy. So, to be honest, when I started making this presentation, I just went online and seen a lot of content that I had seen before and a lot of new content. And I kind of realized that everything that needs to be said about chaos engineering has been said. There are a lot of videos out there, a lot of content that's very cool. If you just open Google and search for Netflix talks, it's kind of crazy. There's a lot of cool stuff. So I decided to talk a bit more about why chaos engineering it's important to me, and why I'm trying to get closer to it. So it all goes down to what we need when we build systems. And I think the most important thing for me is resilience. So if you just Google for resilience, this is the first definition that comes up, which is the capacity to recover quickly from difficulties. It's a very clear and nice definition, but sometimes, what does it really mean when it comes to designing systems and infrastructures? So we can use here a lot of very nice terms, such as self-healing system, elastic infrastructure, whatever you want to say. But at the end, what really matters to us when we put something out there in the market is availability. So that's this nice formula, which I guess all of you have seen before, which is how we calculate availability, right? It's the uptime divided the uptime plus the downtime. And it's a very easy and simple concept, but the truth is that we tend to forget about it. We tend to forget about it because we give it for granted. If I think most of the companies I've been working with, it doesn't matter if it's a small startup or if you're doing some consultant work for a big enterprise. The truth is, availability is something we are so used to that we don't even think about it. I don't even remember, but does any one of you remember when it's the last time they tried to access Gmail and it was down? I really don't remember it, or Twitter or Facebook. Every time it's open that they're up and running. So we give it for granted, and actually, the cloud is great in that sense, because there are so many things that are there ready for us that we don't really have to worry about. So at the end, that's what we do, right? we kind of design infrastructures, but applying some principles that we find on books, that we have maybe from our experience, or we find in documents, or most of the times Stack Overflow. So yeah, and I'm not saying this is wrong, because actually, you know, someone has knowledge, pass it into a book or in a nice article, and it's good to, you know, to learn from them. But is it really enough to make sure that we're doing something that's good? Are we really thinking about everything that can happen? So most of the times, after, you know, just going through design infrastructure, following best practices, then we do this. We put in place some good monitoring. You know, we get some data from our infrastructure. Then we set up some nice alerting. And in the best possible case, we also create some kind of automation to self-fill our approach when it's possible. It's not always possible. Truth is that data is great, and I 100%, I'm a huge fan of data-driven decisions, but the data is not always enough. Mostly because there are some trends you can prevent by looking at data. Let's say, you know, you have a growing number of users, and you start seeing that your database is getting slower, or, you know, you maybe don't have enough servers in your front end. So there are some things you can make better, but sometimes you get data just when the system has already been done. So, you know, that's kind of hard to predict. In a real life scenario, most of the time, sometimes you may put in place some automation and say, okay, I have an auto-scaling group that's going to scale when my CPU hits 70% of CPU or something like that. But then eventually it starts scaling, and for a reason you don't even know, servers start going down. And you're not prepared for that, right? So I just want to share some couple of insights I found. So I read a very nice article on Atlassian's blog. So in 2017, Satisfied customers have posted more than 100-year work on time. And to me, this is like kind of crazy. In 1 year, 100 years of downtime. Which makes me think that, right, if I go back to the previous slide, probably the way we're architecting our stuff is not really that reliable. It's not perfect, you know? Because even cloud providers can fail. We give a lot of things for granted because, you know, the more we use managed services such as, I don't know, RDS if you're on AWS, serverless stuff, you could be using, you know, hosted versions of Kubernetes. So we give everything for granted, but the truth is that even cloud providers fail. So this is the number of incidents during the AWS outage last year. It was, I think, in February. So as you can see, there's a big spike. And I think, you know, how many of you remember that day? It was February, right? Okay, so, you know, there's something we're still not considering. There are many variables that we don't control. That's the point. We can predict a lot of things, but not everything. And that's where, you know, for me, it comes. You know, I'm kind of very obsessed with performance and with making sure that if I do something, then I don't have to go back again and firefight and be on the system all the time, because that really obsesses me. So we need to start thinking about the concept of chaos. So this is, again, Google's definition of chaos. So the property of a complex system whose behavior is so unpredictable as to appear random. So basically, for me, that means something you just don't know. It happens. There are many variables involved, and and you don't really have a clue of what's going on. For example, again, the AWS outage. I think it probably took a while to a lot of people to realize that it was actually an AWS outage. So that's where kind of the concept of chaos engineering comes along. And and for me, it's about creating a system that can survive chaos. That's actually not for me. That's what it's about. It's not really about creating chaos. So, on the internet you can find many articles that say what we've learned from breaking production for 10 years. Yeah, it's great, amazing. But truth is, chaos engineering is not really about breaking things, but it's about how you survive that kind of failures that you didn't predict before. So, the term has been around now for quite a while, and it's probably been also a bit abused in the last 2 or 3 years. It seemed quite interesting to me. I wanted to create that kind of chaos timeline. So, it's actually quite an old thing. So Netflix started with the idea of chaos engineering and building a system that can resist to chaos around 2010, and they came up with this tool called Cismondi. And then, as they validated it, they thought it was a great thing, and in 2012 they made it open source. Great. So this is a funny one. In 2014, chaos engineer became actually a job. It's great. Well, what do you do? I'm a chaos engineer. I break stuff. That's great. And that's me in 2015. I still didn't know anything about it. Because the truth is that it's been around for a while, but just now it's becoming kind of hot. But even if it's a hot term, not many companies are actually doing chaos engineering. And there are many reasons because of that. And this is one of those. You go out, you got quite excited because you see, at the AWS reInvent, a talk of Netflix engineers or someone else saying, yeah, we're breaking production all the time, it's so funny. Or Google's guys who said, yeah, we're doing it all the time, it's great, we put a team together in a room that they just there with the purpose of breaking stuff. Cool. But, is there anyone here that works in Google or Facebook or... Truth is, not all the companies have the same resources that the big companies have. So you might think that it's cool, it's great, you would like to try it, but then you go out there and you start seeing chaos monkey, latency monkey, conformity monkey, and Dr. Monkey, I don't even know what that is. Lots of monkeys and other stuff. Even this nice concept of failure injection testing and CHAG, which is chaos automation platform. There's lots of tools, lots of knowledge you need to have. You also need to, and they talk a lot about monitoring your chaos, getting insights, and then set up your chaos environment. And at the end, you think about it and say like, guys, I just don't have time for this. Truth is, your engineering team will have everything but time. Most of the, in very real world, especially like in startups where you're trying to deliver things fast, and sometimes even in the enterprise, right? Because they move very slow, so everyone's super committed. You have some things to do, and they say, like, yeah, I heard something about that chaos thing, but I don't think it's useful. So, and following on this topic, there's this very nice website, Principle of Chaos. I'm not going to read all this slide, but it seemed kind of funny to me because you know, you have like chaos in practice. So start by defining steady state as some measurable output of a system that indicates normal behavior. To me, I just read the first point and I say like, that's okay. It seems like going back to uni. That, by the way, I didn't finish. But, so it's like there's a lot of things, there's a lot of concepts you need to know. There's probably too much stuff to do if you want to be like Netflix, if you want to be like Twitter, or Microsoft or AWS. It's kind of becoming a pattern for all these big companies at the moment. And I'm not saying it's not great, because if you had the opportunity to apply the same pattern they apply, that would be awesome. You know, if you had a team dedicated just doing chaos engineering that could actually, you know, monitor things you do and the things you break and you know, do lots of studies around it, then that would be the perfect world. But at the end, you know, as you're just like, if you're just like me and you're trying to get something out from chaos engineering without having all the time to actually, you know, work just on it, then, you know, maybe you ask yourself, but you know, what if I just wanted to break something? I just want to break something and see what happens. You know, I wish I would have the team and the time one day to do all those cool things that the big companies do. But you know, it's not always like that. So truth is, you can start by doing small things. You can start by breaking small things, and you can start by understanding how your system reacts to small things. And you know, I was way faster than what I expected. But I'm just going to show you something. Let me just... Okay, right. So, let's say that you, for example, you know, one nice things about cloud environments, you know, as we heard in another talk before today, is that actually you can use APIs for everything. So what if you, for example, could just take the concept of breaking stuff and write in a very small Python script that heals your instances? So while we were talking, these are all the instances that have been killed in a Kubernetes cluster. I'm just going to show you in a few minutes. But not just that, instances are just a part of it. But actually, there are many other things. If you use Kubernetes, you might know that most of the times, now it's becoming a bit more stable, but at the beginning I used to have a lot of problems with networking, DNS, and you know. So what if I could, for example, have something also that, oh, it's not that, sorry. Yeah. So what if I could also have something that takes some kind of you know, system pods, cube system pods, and start killing them, and you know, and actually see what happens. So the resolution doesn't have, unfortunately. Let me just make it a bit smaller. So yeah, just to let you know, here I'm just killing some random pods. Here I'm just checking if my cluster is still up and running. And at the same time, here I'm just somewhere here. I'm just killing some instances. You know, this is probably not the nicest and the most elegant approach to the problem. But the truth is that it kind of works. You know, it's a small incremental step from nothing to get to do things at scale. And you know, there are some cool things happening. just kind of realized today that, let me go back in here. So, as you might understand, product design is not one of my best qualities. But this is like a very small Python app. It's just like basically a Flask Python app rendering some Java template. And it's working. And it's working while instances are going down. And I've stressed quite a lot today to see what happens. I set up some monitorings in Postman tool, and even uptime just to see what happens. And actually, I kind of managed to break it a couple of times. As you can see, there are a couple of red lines. So, and you can at the point just start getting some data. For example, what is the most common thing that prevents my nodes to come up again? Or what are those components that actually, when fail, cause more trouble? Why did I have this spike on latency? What was broken at that point? So getting all that kind of information, even if this is a very, very small and simple example, it really helps you. And you know what? The point is, you don't even need to do it on production. It would be great, again, if you can. That's amazing. But you don't need to. It's not that if you don't do this kind of experiment in production, if you don't, run the whole Netflix cows test suite, then you're not able to do anything. You can start like small incremental steps and see how many things are actually working. Let me see if I don't know if you can see that. But it would be great to show you how many instances have gone down today.
Just click across them.
Yeah, I can. Oh, sorry. This one. Yeah, you see how many instances are terminated, things that are going up and down. And the point is, this is still working. It's working fine. And I've done many other things, such as running load testing together with killing instances and killing system pods. You can push it a bit farther by even kind of trying to isolate a whole AZ in AWS if you're in AWS, or even just trying to see what happens if you deploy while you're breaking stuff. There's many things you can do. The truth is, it's useful and it's great to do. You don't really need to be Netflix. You don't need to be Twitter. You can actually start by breaking small things and see the benefit of it. And that's pretty much it. Yeah.
Finished? Yeah. Any other question for Gabriel? Just the need, depend on you.
Okay, so this might be a question that you can't answer, but I'd just like your thoughts on it. So, great talk, fantastic topic, and whenever I've looked into this chaos stuff with a customer or a project, their response has always been, oh, that's great, we want to do that, but we know if we set it up, our app will break and everything will be on fire. So let's just kind of forget about it. So how do you encourage them to use it, even though they know that things might not be right? Because I guess you start with a point where you're not quite resilient, and then you run it and you find those pain points, and then you fix it all. So how do you get them to adopting, knowing that stuff will break?
I think one of the most important things for me is, and that's why the world talk is about doing incremental steps. and knowing that you don't necessarily need to run it on production. So you can start building your system based on the fact that you have something that's going to break. And you can build your system from your development environment. If you have a pre-production environment very similar to production, then run it over there. And when you're confident enough, then maybe you can start bringing that kind of things. Of course, if you listen to Netflix talks or any other method that rather does chaos engineering, it's not really easy to bring it in production. You need to have a set of, first of all, a team working together when you do this kind of experiments, but also have some kind of short-circuit mechanism. So if something goes wrong, if you see that the error rate is being higher than what you're expecting, then you just short-circuit the experiment. So you need to build a framework that's robust in order to bring it to production.
Excellent. Any other questions? No? Okay, in that case I think we're done. Thank you very much, Gabriel.